Okay, so today's video, this is video 17. This is called Translations of Absolute Value Functions. Just a little abbreviation there. So the goal for today, two things. One, to graph these absolute value functions on your calculator to save you a little time and make sure you're accurate. And two, understand the cause and effect with functions. So basically how different things we can do to each absolute value function will change how it looks and where it goes and stuff like that. So first off, I'll show you the most basic absolute function graph. You've already seen it before. Y equals the absolute value of x. This is actually called the parent function because it's the most basic of absolute value functions, right? There's no extra stuff multiplied or added inside or outside, and it's all just simple. Y equals the absolute value of x. This is the most simple function. Every other absolute value function is just a different version of this, and they're all being translated in different ways. So what I'm going to do now is walk you through a few translations and kind of show you what they do. So here's one. Instead of y equals the absolute value of x, I have y equals negative the absolute value of x. What this negative does right here, it's a reflection over the x-axis. So again, to review, this line right there is the x-axis. When I go from just this to that, it takes this function and flips it over. So basically, every y value becomes negative. Otherwise, those the exact same graph. Like here's the point right here. That's the point 3, 3. Well, this point is the point 3, negative 3. So you kind of see that translation right there. That just took it, it's symmetrical, right? It's a reflection. So you have some symmetry going on here. And that's what this does, this negative sign here. You see a negative in front of the absolute value sign, that's going to make it go face down instead of facing up, like this green one does. This green one faces up, the orange one faces down. Okay, next one. So here, instead of going from this to negative, I just basically put a 2 in front. So now it's y equals 2 times the absolute value of x. What this does is make the entire function steeper. And you notice that here. The green one's the original function, right? The parent function. This is the function, the new one. I put a 2 in front, and that 2 makes it basically twice as steep. That's a good way to think about it. It's twice as steep. So a number more than 1 goes here, it gets steeper. Something less than 1, and it gets less steep. It actually kind of falls down. And I'll show you that right now. So if I also have y equals 1/2 times the absolute value of x, that one looks like this. So you see that when I have a number less than 1 multiplied, it makes it kind of less steep. That's what that, so more than 1, more steep, less than 1, less steep. And of course, if I put like negatives in front of these, it would just make it go down. So if I put that negative there, it becomes this function here. So the negative will flip it over and become a little steeper. So the multiples in front, whether they're negative or a number, will kind of change how narrow or wide the arrows will be or where they face. We can also take that function and move it left, right, up, and down. I'll show you that right now. Okay, for this example, I have 2 new functions, either the absolute value of x plus 5 or the absolute value of x minus 3. This plus 5 here, this is going to be moved up 5 spaces. That plus 5 at the end will move it up 5 spaces. So it's basically the same graph, but instead starts up here and goes up here. So this is the orange function. Just took it and basically raised it up, picked it up 5 spaces. So this brown one, can you guess what it does? This one goes down by 3 spaces. So I've basically taken the function and I've pushed it down 3 spaces, and it looks something like this. So at the end of the function, a plus something will move it up, or subtraction will move it down. Think about the y-axis, right? A higher number goes up and a negative number will go down. So that's another translation. We have 2 more to show you. So here we go. Okay, so again, I've graphed the original parent function. Now I have a new function. This time, instead of a plus or minus number on the outside, I've got here on the inside the absolute value. So what will that do? Well, I'll give you a hint right now. It's going to either move it left 3 or right 3. Can you guess which one it does? You might think left 3, but you'd actually be wrong. This one, believe it or not, the minus 3, will move it to the right 3 spaces. So my new function will be over here. Let me just get this graphed right. There we go. So that's the thing. With the numbers on the outside, plus or minus, plus goes up, minus goes down. Inside, it's the opposite. So with the inside, subtraction goes right, and then addition would go left. So one more graph I could have is like y equals the absolute value of x plus 4 on the inside, right? The absolute value of x plus 4, this one would go left 4 spaces from the start, right? So it started here, but now it's going left 4 spaces, 1, 2, 3, 4, and then it looks something like that. So you see where I started with the green function. This one took the green function, went right 3 spaces. This one took the green function and went left 4 spaces. So those are all the basic translations. So I'll kind of define them all for you on the next page. So given that, I'm going to write this sideways here, y equals the absolute value of x, just turn your iPad over or cock your head to the right so you can see that upright. This function here is what's called, again, the parent function, because it's the most original, right, the most basic of this type of function. Like, for example, y equals x would be the most basic line, like solid line. This is the most basic absolute value function. Whoops. So when you have a negative in front of it, it reflects it over the x-axis, so it looks like this, upside down v instead of right side up v. Again, when you have an a in front of the x, like something multiplied, it's like 4 times x or 1/3 times x. If that's a number more than 1, it gets steeper. So something like this, right, really steep. If a is less than 1, so like a fraction, it gets wider. So something like that. You also have the Brown functions here. So you have x, and the absolute value of x, and you either add or subtract some number at the end. So outside the absolute value, that's the difference between the brown one and the dark blue one here. When you add, you go up. When you subtract, you go down. So think about plus is more, subtraction is less. And then finally, when you have a number add or subtract on the inside, it might be the opposite of what you think. When it's addition, you go left. In subtraction, you go right. So let's look at one function that has a few things going on at once, like this one here. So we'll say y equals, so instead of having this, right, the most basic parent function, I'm going to have this function. So y equals 2 times the absolute value of x minus 2 plus 4. So what's happening here? Well, it's getting steeper because of this 2 right there. With this right there, it's going right 2 spaces. And then with this plus 4, it's going up 4 spaces. So I'll kind of draw my grid over here. And so normally in the green, I had something like this, right? This is the parent function. This is what I started with, right? The most basic absolute value function. But now it's twice as steep. Well, first of all, it's going right 2 and up 4. So instead of starting here at the origin, 0, 0, I'm going to instead start here. And now it's also twice as steep. So instead of going like this one did, up 1 over 1, it's going to go up 2 over 1. So there's a point right there. There's a point. There's a point. And there's a point. So this is my new function. I didn't do any hard calculations. I just knew that it would move differently based on the changes that were made to it right here. You could have also made an XY table if you really wanted to. I'd probably go like, -1, 0, 1, 2, 3 or something like that and just see where it goes. And fill in those points right here if you wanted to. You could always make a table. Or better yet, y equals 2 times, what was that, x minus 2 plus 4. I can also graph this on a calculator, just like this. Here's how I type this in. So it looks just like this when you type it in your calculator. So instead of having the absolute value bars, what your calculator does is it just use the function abs and in parentheses x minus 2 and then plus 4. This function here is located in the math. You hit the math button and then arrow over 1 to the right, and the first option will be abs. So poof, there it is, right? It's the number option, so again you hit math, so you'll be here, then you arrow over 1 to the right, so hit enter there. So first you would type 2, then hit this, then x minus 2, close parentheses, plus 4. You graph that, and it looks something like this. So you see the function here being graphed, and again, look at it in orange, right? It's raised up, a little right, a little up, and over here you see it's a little right and a little up. And this one actually is twice as steep. It's just that because the calculator is wired and is tall, it doesn't look that steep, but it actually is steeper than normal. If you want to graph the original parent function on your calculator and see how they differ. So I know I threw a lot at you for this video, but I just wanted you to see it all. We'll do much more in class on Wednesday or Thursday if you're in Mrs. B's section. So just keep that in mind. If you have questions, get this all in your notes. Ask them when class starts, but we will do more practice with this. You will do a lot of practice with this in class. So that's all I got for now. Thank you for watching the video. I really appreciate it, guys. I know that sometimes new things can be difficult, and so far, for the most part, you guys have been willing to adapt to this change, and I really appreciate it. Mrs. B and myself both thank you all very much. So, see you in class. Have a good night.